Hello everyone, I'm Nansumba Mary Vanessa presenting a project of tax transportation. Like a brief description of our project of the problem, that's the project. Like 80% of the total population in our country are always moving from one place to another. Therefore, necessitating a need for an effective and efficient transport system, but most individuals are inconvenienced with the means of transport to reach their destination. This causes delays and it's time consuming. These means are unstable and unreliable, especially when there is need to move things or services urgently from, for example, a sick, thus leading to loss of lives due to the delays in the road during the movement. This system will increase the efficiency and effectiveness in the transport industry. This will also help to solve the above-mentioned problems and reduce on congestion and jam. Datasets and its descriptions. The dataset I used for my project is public transport, and you can check out this on Kaggle. You can go there and check out some datasets. And the dataset will include the following. It will include time measurement in order to predict or estimate the time taken from the pickup point to the destination. This will also include measurements of distance from the pickup point to the drop-off point. And it will also help in prediction of charges. Like these charges can be estimated or predicted according to the distance moved. There can also be predictions of time of weather. Like for example, when it has rained, some roads may be busy, others may not. The factors considered to select the dataset. I considered the distance to be moved from the pickup point to the destination. This distance can be measured in kilometers. I also considered the duration or the time taken from the pickup point to the drop-off point. And this, when we look at these two factors, they can help us to determine the effectiveness and efficiency of the system we are developing and to check if it meets the goal. Factors involved in the datasets, the nature of the individuals. Individuals can be the people who are going to use the AI. We can target private individuals or public. That those people who use public means, like taxis or those ones who use their own vehicles. The nature of the agents. Agents are the means we are using or the vessels used for transport. They can be like taxis, motorcycles, a bus, and Uber. The nature of the route to be used. Like as we know, some roads are tarmac and some roads are untarmac. Like untarmac roads make it inconvenient for us to use some means of transport because they have potholes and sometimes they are unreliable, especially during the rainy season. Weather changes also affect the rate at which the means of transport like move. Since when it rains, it causes the roads to be muddy. Like we have the Bayesian theorem. This is a machine learning concept that helps to determine the probability of one event occurring with uncertain knowledge while the other event has already occurred. This can be derived from using the product rule and the conditional probability of event A with unknown event B. This theorem, it can be put into a layman's language. For example, we are considering the probability of another event occurring given that an event has already occurred. Like for example, we are saying, if I go to the hospital, I'll get healed. The condition there, for this case, we are saying, if I go to the hospital, I'll be healed. That means it makes it a necessity that if I go to the hospital, I will get healed. And we have these two equations here, and we are saying probability of A union B is this and this, and we are making the probability of A given B the subject to get this, to derive this equation for the Bayesian theorem. And the two events are independent, which means that the probability of the outcome of both events does not depend on another. Then we have the naive bias. The naive bias is a supervised learning algorithm which is based on Bayes' theorem and used for solving classification problems. This theorem works on conditional probability. Then what do we mean by conditional probability? Conditional probability is it's where something will happen given that something has already occurred or taken place. Here we are taking an example that if I go to school, I'll learn. Now, here where does the condition come? We are saying if. That means the condition is if I go to school, I'll learn. But if I don't go to school, I won't learn. So making the condition to be going to school. Yeah. This can also be demonstrated as you see here, the conditional probability. Then we have Bayesian's network. Bayesian networks are a type of probabilistic graphical model that can be used to build models, for data and other expert opinions. This can be used for a wide range of tasks, including predictions. This can be weather predictions, like predicting whether a medicine works, anomaly detections, diagnosis. These diagnoses, I think they are mainly in the medical sector, automated insights, reasoning, time series predictions. These ones and decision making. Yeah. Then we are comparing the Bayesian theorem with the naive Bayes. We are saying Bayesian theorem assumes independent events, meaning that the outcome of one event does not depend on another. Like the real difference between these two events, these two theorems, it's like the naive has the concept of condition, but the Bayes does not have the condition. Like for the naive's Bayes, it assumes conditional independence, as we said before. This means that the occurrence of event A does not depend on event B. Then we have the naive Bayes and the Bayesian's network. We are saying the naive Bayes assumes that all factors are conditionally independent of one another, permitting us to use Bayesian's rule for probability. Since we said that Bayesian's rule makes all events are independent of each other, the probability that one event will occur does not depend on another. Then we are saying the naive Bayes classifier is a technique to assign class labels to the samples from the available datasets. Like our datasets can be like things datasets can be, for example, we are having doctors and they are developing a drug. Like our datasets can be individuals those drugs are being used on. Yeah. And the labels are like, for example, I've given individual 1, that's a label. Individual 2 is also a label. And we have to monitor for their outcomes. Yeah. That was in supervised and unsupervised. You look through that. Then we are looking at the Bayesian networks. A Bayesian network does not have such assumptions, like assuming conditional independence. The independence in the Bayesian network has to be modeled. This one, it's from the programmer that they directed a cyclic graph formed can be learned by the machine. What I see about Bayesian networks, it's all about the machine, and the person has to train it. Like the machine starts learning slowly, and it's a gradual process. This is a graphical model that represents a set of variables and their conditional dependence. For example, if we have an infection and we want to find out a solution to that infection, we can use, they can be connected. The infection and the symptoms can be connected using the Bayesian networks. Therefore, this can be used to predict the probability. Oh, sorry, this is an I. The probability of the existence of the infection. Yeah. Then here, I have some links to the websites I used for my presentation. Please subscribe to my YouTube channel, like and leave a comment. Thank you.